Now, so you just got to know a cyclotron, right? You just heard the word cyclotron. Now, let's see what is a cyclotron. See, before we start, let me tell you why cyclotron was actually invented. See, long before, like around early 1900s or during that period of time, so people wanted to accelerate the particle. See, by then proton, electron were discovered already, right? So they wanted to actually know how to accelerate these particles. So what they did was, so the positives are a long tube, a cylindrical tube, and then there they were accelerating. But if the particles has to be accelerated to a very high energy, then cylindrical tubes, long cylindrical tubes were not efficient. Because see, we have to keep meters and meters of cylindrical tube. See, keeping a meter of cylindrical tube is not an issue, but it has to be vacuum, it has to be proper, like it has to be coated with platinum and all these things, because outside radiation should not come and interfere with the particle. So practically it's not possible. I cannot have meters together of platinum coated cylindrical tube, right? So we wanted something economical which everybody can use it, right? So two scientists, okay, so Lawrence and Livingston. So these two people, they come across a very brilliant idea that why can't we use a circular method to accelerate the particle? Because see, imagine you write one circle, okay, you cut it open and you make it into a straight line. It's going to be a very huge line, correct? So instead of making it as a long tube, so what we'll do, we'll close it and we'll make it into a circular path. That's the reason why it's called a cyclotron. Okay, there is a cycle which is moving it. Okay, cyclotron. Okay, now, so this is why cyclotron was actually invented. Alright, let's see what is the principle behind the cyclotron. Okay, see, the principle behind cyclotron is very easy. Just now you guys got to know that if you have a charged body moving with a velocity of v in a magnetic field, then it forms a circular path, correct? The same principle we are going to use here also. Any charged body which acquires a velocity in a uniform magnetic field, it follows a circular path. So we are going to use the same logic for the cyclotron. Okay, so let me tell you how the working goes. Alright, see, working is in between the two D's. Okay, see, we'll just show you the top view of the D so that you guys will understand it. See, there are two D's, and in between we keep the charged body. Okay, see, when we say charged body, don't think that we are keeping one proton. So it makes no sense, and you can't even get one proton like that. So what we do is, we keep an ionized gases. Okay, so it could be ionized hydrogen or it could be ionized helium, because helium nucleus is nothing but alpha particle, right? So what we do is we keep ionized gases in such places, and then so these two D's, see, they are in a magnetic field, correct? So we have magnetic field, we have a charged body. Now for the velocity, what we do is we connect these two D's into an RF oscillator. RF is radio frequency oscillator. Okay. Now the job of the radio frequency oscillator is to change the polarity of the D's. Okay. So to change the polarity of the D's. So at once, let's say this is positively charged, this is negatively charged. Now what happens? The positively charged, it attracts towards the negative part, correct? So if it is negative, we have velocity and charge and magnetic field. So what happens? It starts moving in a circular path, right? So as it reaches 1D, then what happens? The RF oscillator, it changes the polarity. Now again, it will move towards the other D, correct? Again it moves to the other D. So what happens here? It forms a spiral path, correct? So as it moves on, increasing in the spiral path, so more and more the particles are getting accelerated, right? As the particles are accelerated, so at whatever energy we need the particle, see, there is a deflector, the particles will hit the deflector and it comes out as a beam of accelerated particles. Okay, so this is how the cyclotron works. Alright, now let's go with a mathematical calculation. Alright, now according to this, see, cyclotron, we have a radius, so centripetal force, and BQV sin theta. Okay, so previous video, we already did this. So the same thing we are applying here also. So we have BQV is equal to mv square by r. So we cancel out the v and v. R is equal to mv divided by bq. So this was the radius, what we figured out, correct? Now, the most important part is the frequency of the oscillator, correct? Because it should interchange the polarity according to what is the velocity and what is the radius of the particle. That is the most critical point here, right? So now, see, the particle, if it is moving from one point to other, meaning it is covering half the circumference of a circle, correct? Because the whole thing is one whole circle, that's 2 pi r. So it is covering half the circle. So instead of 2 pi r, we have pi r. So pi r is the distance the particle is covering with a velocity of v. So what will be the time taken? So time taken will be pi r divided by t. Sorry. The time taken t will be pi r divided by v velocity. I apologize, it's pi r divided by v. Now, in place of r, so substitute whatever we got before. R value is what? mv by bq. Correct? So if you substitute, you have pi by v into mv by bq. v cancels. Correct? So as v and v cancels, we have t is equal to pi into m divided by b into q. Correct? So this is the time, whatever we have. Now, since we have time, now, see, the total time t we calculated, correct? For half the cycle, what will be the time? That would be t by 2. So t by 2, if you try to calculate, so t by 2, then this will be pi into m divided by 2bq. Correct? So this is the time period what we have. So once we have the time period, using this, what we do is we calculate the frequency of the cyclotron. Frequency of the cyclotron is nothing but frequency of the RF oscillator. Okay, so that will come out to BQ divided by M. Okay, so frequency nu is equal to BQ divided by M. So what we come across is, as the magnetic field is very high, frequency becomes very high. Or if the charge is very high, then frequency is high. Or if the mass is very low, then the frequency is very high. Okay, so we come across this as the frequency of the cyclotron. Alright, so this is how a cyclotron works. So let me just recap the whole thing again. So what we have is, we have two Ds, we have two magnetic poles, and then we have a charged body which is kept in between the Ds. Now, once we have the charge, the Ds are connected to the RF oscillator. The RF oscillator changes the polarity of the Ds. As it changes the polarity, it forms a circular path, actually a spiral path. As it moves on the spiral path, the radius keeps on increasing. The radius keeps on increasing, velocity also keeps on increasing. After some point of time, once we meet the particle, we shoot the particle to the deflector. By the deflector, the particle comes out of the cyclotron. Okay, so the frequency is given by BQ divided by M. Alright, so in the next video you will see the limitations of a cyclotron.